As we start our new unit of statistics, the first concept that we're going to talk about is simple probability. So simple probability is based on an experiment. So what is an experiment? It is an investigation about an outcome happening. And so we can say it's going to have varying results. And you've seen this in science when you've conducted experiments before. So what's an example of an experiment? It could be rolling a dice. It could be flipping a coin. We're just going to say flipping a coin. And then an outcome is what happens in that experiment. So it's a possible result from the experiment. And so if I take the example of flipping a coin, what's a possible outcome? Maybe it's getting a heads. Okay? So what is sample space? So a sample space so an outcome is what could happen. And then the sample space is just the set of all possible outcomes. Now, here's what I want you to remember. You've got this word here, the set. So do you remember in algebra, when we have a set of answers, what we have to use that notates a set? We have to use brackets. So if we are talking about flipping a coin, one example could be getting heads, okay? But the sample space is going to be heads and tails. That's all the possible outcomes that could happen, okay? And remember, it's a set. There's more than one answer, so I have to have those brackets around it. All right, now let's look if we want to give the sample space. So we're looking for the sample space and number of outcomes for each experiment. So first we have to know a state that begins with the letter O, okay? So if you've memorized your states in alphabetical order, Alabama, Alaska, Arizona, you've got Ohio, Oklahoma, and Oregon. So we have Ohio, Oklahoma, and Oregon. Okay, those are my 3 states, and so the number of outcomes would be 3. I have 3 in my sample space. So a day of the week is chosen. So what do I have to choose from? Well, I have Sunday, I have Monday, I have Tuesday, I have Wednesday, I have Thursday, I have Friday, and I have Saturday. So in this sample space, I have a total number of 7 outcomes, okay? All right, so there's a lot of vocab in this unit, so we got to remember outcomes in sample space is super important. So when we go up to probability is I'm using the information, but what probability is, it is a measure of the chance of a specific outcome occurring. And we use P of E. So P means probability of an event occurring. Okay, so that's P of E is how it's read. And so this can be expressed as a ratio of favorable outcomes to the total number of outcomes. And this ratio can be written as a fraction, it can be written as a decimal, or it can be written as a percent. But the sum of all probabilities in a sample space is equal to 1. Just like if I turned 1 into a percent, it would be 100. So it's all based out of one whole unit. Okay, so that's my definition of probability. So if I look down here at the examples, and let's say I've got a spinner over here, and I want the probability, remember, this is a favorable event. So the probability of spinning a 9 is going to be 1 out of the total number of possible, and I get 16. So there are 16 outcomes. So a 1 out of 16 chance. Now, Remember, you can express it as a fraction, and then if I divided 1 divided by 16, I can express it as a decimal, and then I can also express it as a percent. So all of these mean the same thing. So, number 2, at least 12. So what is the probability of me rolling of at least 12? So what is my sample? What could give me at least 12? Well, 12, 13, 14, 15, 16, that's a possibility of 5 out of the total amount of 16. So 5 out of 16, and then I would do 5 divided by 16, and that gives me 0.3125. And if I express that as a percent, I would move it twice over to get 31.25%. Okay, so now let's look at a perfect square. Well, what are the perfect squares? 4 is a perfect square, 9 is a perfect square, 1 is a perfect square, 16 is a perfect square. So you have 4 possible outcomes of that happening, of the favorable event out of 16. I still want to simplify my fraction. So I'm going to simplify this to 1/4, and 1/4 is 0.25 or 25%. Okay, the probability of not shaded, so 3, 4, 5, 6, 7 numbers are not shaded out of the total amount, which is 16. And again, 7 divided by 16 is 0.4375, and then to turn into percent, it's going to be 43.75%. Okay. All right, so that's kind of an example of your simple probabilities. Let's flip over to the next page. We won't do all the examples. I feel like you kind of have the point here. All right, let's do number 4. All right, a month of the year is chosen at random. Find each probability. So it starts with a J. So what months start with a J? We got January, February, March, April, May, June, July. That's it. You have 3 months that start with J out of the total number, and there are 12 months in a year. So 3 out of 12, which reduces to 1/4. So then I'm going to convert that to a decimal and then as a percent. Okay, what is the probability of a month starting with the letter T? None. There are no months that start with the letter T. So 0 out of 12 equals 0. There is a 0.0% chance and a 0% chance that this is happening. But I still express as a decimal and a percent. Okay, has at most 30 days, which means it doesn't have 31, it doesn't have 21. It has at most 30 days. So I can't believe some people haven't seen this, but like if you take your knuckles and we start over here and we do the days or the months of the year starting with January, if it lands on top, there's 31 days. Okay, if it lands in the middle, there's less than 30. So January has 31, February doesn't, March, April, May, June, July, but then start it over. So January, February, March, April, May, June, July, August, September, October, November, December. Okay, so the months that has at most 30 days are not going to be your knuckle months. They're going to be the ones in between. So February doesn't have 30. So January, February, March, April, May, June, July, August, September, October, and November. So you have, I just lost, you have 5 months. January, February, March, April, May, June, July, August, September, October, November, December. So you have 5 months that have at most 30 days. Boy, that was a painful lesson. Out of 12. And so then, when I do 5 divided by 12, I get 0.417, and then I express it as a percent, and I get 41.7%. Okay, so that's how you're going to read those. Let's take a look at number 7 real quick. So first you have to know how many cards are in a deck. So there are 52 cards in a deck. There are 4 suits, right? All right, so the probability of me drawing a queen, there's a queen of each suit. So it's going to be 4 out of 52, which reduces to 1 in 13. So if I want to express that as a decimal, it's going to be, not that, 0.0769, and expressed as a percent is 7.69%. Okay, what's the probability of me getting a red 3? Well, there's two, you have black, club, and spades, and red, hearts and hearts and diamonds. And so the hearts and the diamonds both have a 3, so that's 2. So you have 2 out of a 52 chance, which is 1 in 26. And that gives me 0.3846, which then becomes 38.46%. And then a spade, there are 13 cards of each suit. So there are 13 spades out of 52. So 13 divided by 52 is going to give me a 0.25, which gives me 25%. Okay, so that's your simple probability. Now, let's talk about a complement of an event. So the complement of the event is the probability not happening. It's the opposite of a favorable outcome. It's an unfavorable outcome. So, of not occurring. Since the sum of all probabilities in a sample space is 1, the probability of an event not occurring is what we consider this, P not favorable E, or we can say it's 1 minus the probability of the favorable event happening. Okay, so what does that look like? Well, let's take a look here. If the probability that it will rain tomorrow is 3/8, that's a probability of it raining, that's a favorable outcome. What's the probability that it won't? Well, it's 1 minus 3/8. And remember, these are fractions, so 8 over 8 is the same thing as 1 minus 3/8. So there is a 5/8 probability that it will not rain, which is a 0.625 in a decimal, or a 62.5% chance that it will not rain. Okay, if the probability that someone will win a game at the carnival is 1 in 24, what's the probability that it will not win? Well, it's going to be 23 out of 24 of it not happening, and those are probably pretty accurate stats. So you've got a 95.83% chance of not winning at a carnival ride. I hope you remember that and save your money. All right. A number from 1 to 20 is chosen at random. What is the probability that it is not prime? Well, how many numbers are prime? So you've got 2 is prime, 3 is prime, 5, 7, 11, 13, 17, and 19. So you've got 8, I don't know why I counted like that, 8 that it is prime. So 1 minus 8/20 is going to be 12/20 that it is, 12/20 that it is not prime, which clearly reduces to 3/5, which is 0.60, which is 60%. Okay, so that's how you read the complement of an event, of it not happening. If you have questions, let me know.